right, let's see what topics we have for today. Today we are.
Are you sharing your screen?
Apparently not. Let me fix that. All right, topics. There's a bunch of stuff that I would like to talk about. One of them is liquid. I think it was Chris who asked about it. Yeah, about liquid, what it is. Some people haven't heard of it, so it would be good to cover that briefly. And you know all about it, about liquid.
Just a little.
Elsa 3 updates. I don't know if I covered the 2.8 release. I think I did last week. It happened last week, I think. Anyway, so Elsa 3 updates. Then I can show the activity execution events for the workflow journal and variable management. Do you have any topics you would like to discuss?
Yeah, I had one question this morning regarding detecting loops in the workflow. I'm not sure if you had
Oh
time
yeah,
to.
I haven't, but let's take this opportunity to talk about the infinite loop situation you mentioned. All right, that's a good agenda. Let's start with liquid. That's a fun one. So I will start the Elsa server so we have something to look at. And it's okay if it takes a long time to start because my brother will be taking his time to edit this and speed it up for the recording. I changed my screen resolution so now it's all weird. All right, that's one. And then I'm looking for the studio. Same problem. I wonder how others are doing it when they record their screens while giving demos. Maybe they have all of the IDEs started up front because it's quite sluggish when recording is happening.
Yeah, I think the screen capture slows things down.
Yeah, for sure.
That's why maybe they use some hardware, capture device or something.
Yeah, maybe I need a better video card or something. Although this is a GeForce RTX 3080, 16 gigabytes of VRAM.
Yeah, but
Anyway,
I think all this works in the software level. So
mm,
I'm not sure how much hardware acceleration it really benefits from.
I see. Yeah, well, I've heard good stories of the Apple M1 chip. Have you ever tried it?
Not really, not a Mac person. Yesterday they announced the M2 chip.
Come again?
Yesterday they announced the M2 chip now.
The M2 already. Wow,
Yeah, thanks, guys.
nice. Yeah, so maybe I will put M2 on my wish list.
Yeah, we'll do like me, wait for M3.
Maybe I should wait for M3, which will happen what next month, next week. They go really fast.
Yeah,
Do you know when they? Well, you just mentioned M2 is about to be released. Is that the case?
so they announced it yesterday because they had this event, WWDC, and then it will be available from July.
Awesome. Okay. Interesting. Well, I'll keep an eye out. All right. So back to the issue at hand. We have Elsa server running. We have an Elsa dashboard 2.8. So let's take a look at the at what is Liquid. As a brief summary, Liquid is a templating syntax that you can compare to others like Razor, where Razor is also a templating syntax that's typically used to create HTML views, and it's a mixture between HTML tags and C# code or VB code. I think they at some point supported. I don't know if that's still the case. And there's many template syntaxes like handlebars is another one, and mustache. In terms of syntax, they look like Liquid, and Liquid itself was created by Shopify. So here they have a Liquid reference. They explain what is a template language. Well, first let's take a look at at an example of the syntax. So here's a very simple example. This only shows the Liquid syntax. It doesn't show any text surrounding it. Typically it's used with HTML, but it doesn't have to be, of course. It could be, I don't know, maybe generating a markdown document, but you want it to be dynamically created based on some data model that you use as an input to your markdown template, where you use Liquid filters and processors or entities. They have filters and tags. That's what they use to basically replace placeholders or Liquid entities like these. This is a thing. I think it's a filter, or in this case, it's immediately inserting a variable at runtime. So it's a way to generate documents like what you do with Razor, or if you have if you use Shopify and you have web pages that you create, then you want to have it render your products, your product catalog dynamically at runtime. So that's a typical use case for Liquid, mustache, handlebars, and the like. Why is Elsa using this? Elsa has, as you may know, a send email activity. And the send email activity has a body. Let's take a look at that. So let's say we create a new workflow and all we do is send an email. So we'll send something from some email address to some recipient. So here we have a subject. This could be a static field, static value, for example, something like this. You could also maybe want to insert a dynamic value, maybe based on some workflow variable or some input that was received into this activity, like a product title. So you would want to insert that. So there's two ways to do that out of the box. One way is to change this to JavaScript. So you could say something like, hey, by this, and then use some variable. Let's pretend this variable exists for a second. And this way we are using JavaScript's string concatenation or some string building to return. So for small, simple strings, this is fine. Now let's think of the body where we probably want to use some HTML. Then using a JavaScript syntax becomes a bit unwieldy. Even more so as your HTML structure or HTML content becomes more large or complicated. And think also about looping through lists of data, like maybe you just purchased something and you want to display the shopping cart or the order as part of the email confirmation. You get the point, right? So that can be very complicated to build with just JavaScript string concatenation. So instead, what is recommended to use is to use the liquid syntax. And liquid, when it's evaluated, it always returns as a string. So this is important. When you use JavaScript, it can return any type of object. So in this case, it's just a string. And that's supposed to happen because the subject input field of this activity expects a string, but other fields like attachments, they don't expect strings. They expect a list of either a path of URLs or a string or a byte array. So in those cases, you cannot use liquid because liquid always returns strings, but you can use JavaScript because in JavaScript, you can actually return other types of objects. So that's an important distinction. So in the case of liquid, you could just say, well, here I have some HTML and I have some body. And then here I could maybe iterate over a list of objects. So using the liquid syntax, we would have to take a look at the liquid syntax here. So this is the documentation for liquid. There's they have a different page where it's more convenient to look at, to have a quick overview of the filters you can use and the tags. Yeah, this is the one. So for example, iteration. Here you use a block. So we could copy this into our body. So let's say we do have a collection variable, then this is the way to access it. Or I think it's variables, and then let's imagine we actually have a variable called collection. It's an object that has a property of products, and this is how you would access it. There is Elsa documentation about liquid syntax used in Elsa, which explains how to access variables. So if you're not sure, you can always go to the documentation website. Then there's a section called expressions, liquid. And then here, for example, if you want to access your workflow variable, so you always start with variables. And so this is like a global object, and then that object contains your workflow variable. So this would be the way to access your variables in liquid syntax. That's liquid in a nutshell. Very handy for certain use cases, such as this one. All right, so let's go over the Elsa 3 updates that I've been working on for the past week. I started with the following item. Let me look it up. The workflow journal. And the workflow journal is, we have it in Elsa 2. It basically displays the execution log records that were created by activities as they execute. And in Elsa 2, they emit two types of records. One is the executing record, and the other type is the executed record. And then those two types are used to compute the time it took for an activity to execute. But this has some issues in Elsa 2, specifically when it comes to composite activities. And what is a composite activity? That is a activity that is like a mini workflow. So it's an activity that schedules child activities for execution. And in Elsa 2, you would see the time it took for each activity to execute for individual child activities, which in itself is useful, but it becomes hard to see what time it took for the container activity to execute. And of course, some container activities could have blocking activities that could cause the workflow to be suspended for minutes, hours, days, weeks. And ideally, from the workflow journal, you would be able to see that. In Elsa 2, this is tricky. In Elsa 3, it's much easier thanks to the notion of activity events or signals. And in Elsa 3, we have two of those. So we have the started event for an activity and the completed event. And the completed event is triggered when an activity completes. So for small activities like write line, read line, etc. would be faster, although read line could be very slow because it actually requires the user to input some line into the console. So that's a bad example. But write line is a good example of a simple activity that executes and finishes immediately. And then there's activities like for each, and depending on the implementation of the iterate outcome of for each activity, the for each activity overall could take a very long time to complete, especially if there are blocking activities in the branch. Let's take a look at that. So here we have the Elsa 3 designer, and I'm going to show one of the workflow instances that I've been testing with. So don't pay attention to the way it looks right now. This is under heavy development, so it's not gonna end up looking like this, but it does help to show what I mean. So first, let's take a look at the workflow itself. So this is the workflow. Let's move this away for a second. And it's very simple. So it starts with a write line activity. You can recognize by this icon. Then it executes a for each activity, and the for each iterates over this set of items. So it's an array of strings. So for each item, it will execute its body, which is connected to another write line, which will simply print the current language. So this is a variable that it will print, and this variable is captured from this activity. We'll get to that in a minute. And then when this activity is done, it will print the text done. So this is the workflow. So I've executed this a number of times. And then this is the data as it's recorded in the database. So what we see here is the first activity is the flowchart itself. So that's basically this workflow itself is a flowchart activity. It started, but as you can see, there's no ended right here. We have to scroll all the way to the bottom to see that it's completed. And using this information, we can tell what time it took for the overall workflow to complete. And of course, for each child activity, we can do the same. So then write line 1 started, that's this activity, write line 1. It started at second 26, it completed 22nd 26, which makes sense. Then the for each activity started. And then the for each, then of course, iterates over each item in its list, and then the only activity in its body is this write line here. So we see that here execute, it completed, then the second iteration, third iteration, and the fourth iteration. And then the for each completed. Now, these individual records are what I want to do. Instead of displaying them as individual events, I want to basically combine them into a single card, if you will, in this list, so that you can have at a quick glance see the overview of the root activities, if you will. So that's start, for each, and done. That's those three cards you would see in the workflow journal. But then you could drill into each card, if you will. So for example, the for each activity, if you expand it, it would show the iterations. So maybe it would have 3 or 4 cards called iteration 1 through 4 or 0 through 3 if it's 0 based, and then you can expand those. So this way it should be a little bit easier to look at the workflow, but we'll see. I'm experimenting with this. Yeah, so this is a work in progress, the workflow journal. Another improvement compared to Elsa 2 is that this journal will be loaded in pages. In Elsa 2, the entire journal is loaded in one call, which is fine for small workflow executions. But a big problem if you have a workflow that executes for a long time, especially if you have looping and branching back into previously executed activities, generating a lot of execution log records. You can imagine loading all of this data when you look at the workflow instance viewer can take some time. That's not good, that should be fixed. But since I'm working on the Elsa 3 implementation of this, I'm fixing it right off the bat. All right, enough said about the workflow journal for now. I've also been working on variable management, and this is completely different compared to Elsa 2 in a few important ways. So let me load the workflow here, and let's go through this workflow again. There's something important going on here, and actually let's take a look at the print current language activity. As you can see, the input, it uses JavaScript and it builds a string based on something called current language. So this is a variable, and this variable is a workflow variable. And to create workflow variables, you click somewhere on the canvas, selecting the workflow effectively. So here you can see that the for each demo workflow is selected. It's a workflow definition, which itself, of course, has properties like definition ID, version ID, the version, its publication status, some labels, etc. So it also has a new tab called variables, and this is where you manage variables. You can add as many as you like. You give them a name, a type, a default value, that's optional, and storage, but we'll get into that in a second. So here I created a variable of type object with no default value. So here I created another variable called current language of type string. So this now exists in my workflow, and here I'm using that. But of course, what we want to display is the current value of the for each activity. So for each item in its list, the first iteration, the value will be C#, JavaScript, etc. The way to capture the current value being iterated on is through the output tab. So activities can have input activities. They are like input arguments of a function, if you will, and they can have output properties, which are analogous to the return value of a function. So the for each activity has a single output property called current value. In Elsa 2, to capture this value, you would either reference the activity directly from, for example, this write line activity to get the current value, or you would set it into a workflow variable using the set variable activity. But in Elsa 3, you don't need that activity for this scenario. Instead, you can directly capture output values, output properties from an activity into a destination block of memory, if you will. In this case, it's a variable. So a variable is a reference to a bit of memory that's stored in the workflow execution context. So yeah, so that's what happens here. And now for each iteration, this variable is assigned the current value. And then of course, whenever this activity executes or any other activity that executes from here on out, will have access to the current value of this for each activity. So that's what we see here. Here is being used. So another important change with Elsa 3 is the storage mechanism of activity input and output. In Elsa 2, all activity input and output would be stored by default as part of the workflow instance document, which on the one hand is convenient because everything is stored always. So even if you have long-running workflows that have blocking activities, then, as you know, the workflow instance gets persisted into the database, goes out of memory, and then when the workflow gets resumed, all of its state is readily available, which is quite convenient. But it also introduces some issues with serialization, as we've seen 1 or 2 meetings ago when we looked at the SQL execute SQL query activity, which as an output property returns a dataset. That dataset is not, it is serializable, but not deserializable by default. That would just basically break your workflow instance as it is today. In order to work around that, we have to mark the output property as to use transient storage. So that means it only exists briefly in memory, and this then affects all subsequent activities that use this value. We have to make sure that all of these properties are using a transient storage provider. In Elsa 3, everything is transient by default. So that means all activity input, output only exists while the activity executes and when its child activity executes. So as long as an activity has child activities executing, the parent activity execution context, they exist in memory, but as soon as that's done, the output is gone as well. Of course, whenever an activity executes, its input is re-evaluated. So this is already persistent as part of the input property of the activity. So that's persisted as part of the workflow definition. But at runtime in the workflow instance, that information gets lost. And if you don't want that to get lost, for example, you want to store some output of some activity for the duration of the workflow, you can capture it using a variable, but variables by default are also stored transiently. So you have to configure your variables in a way, and that's where the storage field comes in. Again, the reason for the transient by default is to avoid situations where you accidentally capture some object that gets serialized as part of the workflow instance document, which is not serializable or deserializable causing issues. So it's better to be very explicit about what stuff you want to save as part of your workflow instance, or even using a different storage provider. Like in Elsa 2, we can choose transient, we can choose workflow, which means the data is stored as part of the workflow instance document, or you could choose a different provider like an Azure Blob storage provider or FTP for that matter. That's flexible and that's here as well. But here in Elsa 3, you configure this storage mechanism on the variable, the workflow variable level, which I think simplifies it a little bit. Yeah, so workflow here, store the output or the variable value as part of the workflow document. There's no blob storage yet. But this is an extensible mechanism. So to see how this works, let me open Postman. Here I have an API request prepared. So this execute endpoint lets me execute a workflow that I created. So the way it works, I have the URL to my ASP.NET Core server, some endpoint path, workflow definitions, the ID, the definition ID of the workflow, and the execute command here. So in this case, the workflow definition ID is this value, so we can copy this. This was already the same value. And then when I hit send, it executed and it returned the workflow state. And the workflow state is a representation of the workflow instance, but just the most basic information. The workflow instance object itself lives in a separate layer, in the persistence layer, and it has more data, but this is the workflow runtime state, if you will. And as you can see, it has a field called persistent variables, and this just stores what variables were captured that were configured to use a storage mechanism. And then because we use the workflow storage provider, that provider uses the same workflow state object and then adds a custom property with its name and then the latest value. And in this case, it makes sense, it's Ruby, because Ruby was the last value iterated. So that means its output lastly was Ruby, and that's the last value stored. For this simple workflow, of course, it's not necessary to persist the current language variable, so we can just change it to not use storage. And if we publish this and then execute again, then we see this is a bug. It should not have displayed anything because the storage drive ready is null, but here it's captured the display text. So that's a little bug that I will fix. But when that is fixed, this should be empty. And that means this variable will not be stored anywhere. And that's okay for this particular workflow, but for long-running workflows, if we had maybe some HTTP endpoint at some point, like here, then this would be blocking, and then we would resume. Interesting. I will check that later. So as I was saying, let's say it resumed at some point when an HTTP request comes in. At this point, when this resumes, the variable would be empty, which may or may not be desirable. Probably in this case, it will not be desirable. So it's important for that variable to be persisted like this. All right, moving right along, infinite loops. So what is an infinite loop? That in C# terms could be a while loop with a condition of true, that always evaluates to true. And if there's no return or break statement inside of that loop, you will basically melt your CPU and your program will execute forever until you kill it forcibly. In workflows, you can set up the same situation. So for example, there is a for activity. I haven't exposed it here, but imagine that this is a for loop and the input condition is set to true, then it will always execute. So that's one way to create a loop. Actually, let's do it in Elsa 2. Actually, let's use the while loop. It's better. So here we say true, and then we say hello. So when this workflow executes, this will run forever. We can risk trying it. Let's see how my computer holds up. But let me be at the ready to hit the stop button here. I'm now gonna let me just introduce a little timer, just a small delay so that I don't freeze the computer. Okay, so this workflow will loop forever. So it will, for every iteration, write something to the console, wait 1 second. And since this is the last activity in the iterate branch, the control flow will go back to while and then execute the next iteration and so forth. So let's give this a quick name. Publish this one, and now we will execute it. So as you can see, it's printing hello every second, and it's never going to stop. So here, of course, I did it intentionally, full well knowing what I'm doing, but it's also possible that you do this by accident, and this could be disastrous, especially if you're changing workflows at runtime in a production environment. If you're not careful, it's easy to create an infinite loop. It happened to me once, maybe twice. And that was a big issue. The entire server would become unresponsive to other requests. So it's a big problem. One way to deal with that is to configure a infinite loop detection strategy in Elsa. There's one out of the box that I will show. First, let me stop this. So here's a sample project in the samples folder underneath ASP.NET, and this is another example of an infinite looping workflow. So it basically does the same thing. Forever, it will set a variable, increase the count, and then this should never execute. So here what we see in the startup, we can configure a cooldown loop handler options. Oh, to configure it, we do it right here. Okay, so we have a loop detector. So that's a strategy to detect workflow looping. Because for some scenarios, maybe you do want to iterate 1,000 times and not have Elsa detect a infinite loop situation. So you may want to either not install it or install it, but maybe cause the workflow to cool down, stop execution after 1500 executions, as an example. So the first thing to do is to install the loop detector here. So here we have an activity execution count loop detector, which is built in, I think. Yeah, it's part of core. And the way it works, it basically counts the number of times a given activity executes. So for each activity executing, it looks up the ID and then increases the count. And then if it reaches some threshold, so the max execution count, which is configurable, it will return true. So then the outer code that invokes this will do something with that. That's the default loop handler. So that's basically saying, in case a infinite loop is detected, how do you want to handle it? So here there's a thing called a cool down loop handler, which is also built in. And so, okay, so the way this works is it does two things. First, it checks if the cooldown event's execution count reaches a certain threshold, then it will throw an exception, ending your workflow. So your workflow will enter a faulted state. But as long as it doesn't reach this threshold, it will induce a cooldown period of a configurable amount of time. So, for example, this could be 10 seconds. Even if you are in an infinite tight loop, after let's say 100 cycles, if that's what it is, if that's how it's configured, it will just stop executing for a minute if that's what's configured, and then it will try again. So these are some default strategies that can be installed, and of course you can install your own logic. All right, so in this code here is actually configuring that cooldown loop handler. So here I'm saying I want to use this handler. This cooldown loop handler injects a options of cooldown loop handler options, which you can configure like this. I'm allowing a maximum number of cooldown events of 3, and then I want to cool down for 7 seconds. So this is one strategy to deal with infinite loops, very important in production environments. Another way that doesn't exist today, but that would be to allow a user, a developer, somebody who has access to the dashboard, to cancel the workflow altogether. Now there is a API endpoint that lets you cancel workflow instances. The current implementation only changes the status from suspended or running or whatever the state may be to cancelled, so that the workflow instance will not be resumed anymore. But this does not impact actively executing workflow instances. So as the workflow instance executes, there's no way currently to cancel it other than killing the server or the application on the server. But what I want to do is change that so that even if you invoke cancel on a currently executing workflow instance, that workflow instance will stop executing, which is very useful in case it is in a tight loop in production, you're panicking and you want to just stop that particular workflow instance. This cancel method should work for you. Once it's implemented, there is an issue for this.
I think this is very important and feels kind of mandatory because
Yeah.
the scenario I faced was a bit that I had a send email activity, and that send email had a timer behind it to cool down. So, for example, it will send one email every 30 seconds. And while I'm updating the workflow, I accidentally deleted the timer. So the send email was pointing back to itself. So you can imagine the flooding happening
I can
continuously,
imagine. Yeah.
sending emails and not able to stop it without shutting down the server. So maybe even some in the designer itself, if there is some UI hint that there is a potential loop or something that can, because that's a user error that can happen anywhere.
Yeah, exactly.
But, yeah.
Yeah, so I'm thinking from the workflow instances view here, when you look at your instance that is running hot, you should be able to cancel it.
Yeah, when I try to cancel it, didn't respond. So I had to stop the server and
And
manually delete the instance from the database.
yeah, makes sense. Yeah, and that's what this issue is about. So somebody raised this in this discussion
Mhm.
where they ask how to cancel a workflow instance that is in a loop. So sounds like similar to your scenario. So yeah, it doesn't work today, but we need to make that work. And here I propose a way to do so.
Mhm.
Oh, actually, this is not my text, I think. No, I just referenced it. I should update this with a proposal of how to implement it.
Yeah.
I'll keep it on the Elsa 3 board as well, just to not forget to implement it there. But I also want this fixed for Elsa 2.9. I think it's an important update.
Yeah.
All right, anything else?
That's all from my side.
That's all from my end as well. Thank you for watching, and we'll see you next time.